Welcome you all to 19th Inaugural Lecture of University of Mordor. It's a great honor to have you all on this occasion. And now, I would like to invite Professor Himan, the Director of Research at University of Mordor, to introduce our professor for the day.
Good evening, everyone. Professor Himan Punchihewa. Professor Himan Punchihewa is a chartered engineer, a past head of the Department of Mechanical Engineering of the University of Mordor, Sri Lanka, and a past secretary of the University of Mordor Teachers Association. He earned his BSc Engineering degree in Mechanical Engineering from University of Mordor in 2001. Soon after his graduation, he started work as a research assistant in the same department on the Swedish International Development Cooperation Agency, SIDA, funded Southeast Asian Regional Research Project on energy, environment, and climate for a period of 1 year. Then, Professor Himan Punchihewa was awarded a research studentship by the Hong Kong University of Science and Technology in 2002 to follow his master's degree in industrial engineering and engineering management. Having completed his MSc, he returned to the University of Mordor in 2004 to take up a lecturer position at the Department of Mechanical Engineering, University of Mordor. After serving the department for 3 years period, he was granted study leave to further his education in design and ergonomics at Loughborough University, UK. His PhD was funded by Loughborough University as well as a project. He completed his PhD in 2010 and returned to the University of Mordor while others stay away from the country. Himan has also undergone different training activities, training programs, teaching and research methods, tent evaluations, sustainable product and consumption, railway transport systems, and many other fields. In his career, Himan has served different universities in various capacities. University of Pune, University of Mordor, University of Jaffna, University of Sabaragama, General Sir John Potala University, and before that, General Sir John Potala Defense Academy, Hong Kong University of Science and Technology, and Loughborough University. His main teaching and research interests lie in the areas of industrial engineering, operation management, and design and ergonomics. His current research work revolves around developing work standards for people with physical disabilities, integrating life cycle thinking in developmental effort, and technology integration in product development. While involved in teaching and research activities, Himan has involved in numerous product development, productivity improvement and planning, and personal training activities in university as well as the national levels. Throughout his 20 years of academic career as a teacher, researcher, and a consultant, Himan has also shown keen interest in community services as well. He has organized and taken part in numerous welfare activities such as reforestation, school development, and social empowerment projects. Now, I cordially invite Professor Himan Punchihewa to conduct his inaugural lecture on positioning the design and manufacturing sector for global competitiveness by embracing Industry 4.0. Thank you very much.
Good afternoon to you all. Dean, Faculty of Engineering, Dean, Faculty of Graduate Studies, my dear colleagues, thank you for the lavish introduction of myself, Professor Gopura. Yes, I was born in Kandy, and it has been quite a journey thus far. My father is a doctor, mother is a nurse, and I had 2 brothers, both are boys. So, 3 brothers, none of them took up medicine. But my elder brother, he did the aeronautical maintenance, migrated to Australia, worked for Toyota. Now he's in the he serves the Royal Australian Air Force. Myself, I came to do engineering. My brother did bioscience, but ended up doing technology as his profession. Now he's on his own, doing his own business. So my parents never pushed me to any profession. He wanted us to do what we like. When I was small, I was into civil engineering. I was doing, I went to see the Mahali, the Victoria project during its construction, and I thought I'll do civil. I didn't know what civil engineering means, but I did that. And I was making canals in my backyard. Then later on, I developed this liking towards electronics, started making circuits. And I did that till my O-levels. And then after that, I shifted to electromechanics. And by the time I reached past my A-levels, I thought I'll do mechanical. That was the ultimate liking that I had. So when I came here to University of Moratuwa way back in 1996, I set my mind to do mechanical engineering. I was all set to do mechanical engineering, and I did that very well. During my school days in Kandy and Colombo, I had many people who inspired me to do engineering, maybe technology. But only after coming to University of Moratuwa, I saw people with great stature. I looked at them and tried to emulate them. And during my first year, it was quite different situation compared to the schools. So I thought I'll be like one person. Then I shifted my thoughts to be like someone else. When it came to my second year, I wanted to be like Professor Priyanta Vijaychandra. I wanted to be like Mr. Gresham Peavis, who is here present online. I wanted to become a professional like Professor Athalagi. And I wanted to become like a person who is very calm, like Dr. PSL. And after some time, I gave up trying to become someone else. I gathered the traits of everybody and tried to figure out who I am. And looking back at my journey, I derive immense pleasure in being a professor and being myself. Department of Mechanical Engineering gave me 4 different things. It gave me a career. It gave me my lovely wife, who's sitting in front of me. It gave me the salary that I'm drawing. And it gave me colleagues and friends, whom I call the Mech family. And University of Moratuwa has molded me into a professional that I can be proud of. I don't know about the others. With that, I should thank all my students, both undergraduate and postgraduate students, for helping me to achieve this. Without the students, any lecturer won't have a place in this world. So thank you, all my students, for molding me into this state. With that, I'll start my lecture. I was thinking what we should, Let me share the screen. Right. I thought of doing a lecture not on what I have done mainly, what should be done to develop this country. So I thought of discussing on how to position the design and manufacturing sector for global competitiveness, embracing Industry 4.0 technologies. And I dedicate this lecture to all the citizens of Sri Lanka. I will initially discuss about the Sri Lanka's economic performance thus far and the design and manufacturing sector in broadly about the design and manufacturing sector, how the SME manufacturing sector is performing at the moment, and how we can achieve global competitiveness and value addition, and how Industry 4.0 can intervene and upgrade the SME sector, SME manufacturing sector, and finally, the strategy that I propose to develop the SME industry sector for Sri Lanka. If I show you something that we all know, the GDP growth of Sri Lanka, it has been like this. When we look at the GDP, we can be happy that we are doing economic activity in Sri Lanka. Over the years, we have been doing very well, and there's a steep increase in the GDP after about, say, 2002. If you look at the contribution, over the years, contribution of different sectors to the GDP, service sector has done about 54%, 55% contribution. Industry sector, 30%. And the agriculture sector, less than 10%. That's where we get the plate of rice to our table. So it has a contribution of just under 10. If we look at the exports and imports, it doesn't show the steep, or it doesn't reflect the steep increase of the GDP when we look at the figures. If you look at the exports, it has always been less than the imports. So how come we have a positive growth, a steep increase in the GDP? If you look at this graph, you will realize our GDP has risen over the years, steep increase due to COVID. This dip is there, but it has increased. Now it's around, say, 80 to 90% billion US dollars. At the same time, you would see that our external debt also has increased. And then, if we look at the total reserves that we have, it's hovering around less than 10, and it's hovering around the 0. So it shows, if I go back to my previous slide, it shows that we are not doing great in the export sector. We are depending on imports and external debt. Hence, we have a big GDP with a huge debt, and our reserves are almost 0. So how can we move forward? We need to increase exports while keeping check on the imports. Sorry, So imports mean USD out. We need to spend money for our imports. Food, commodity items, services, if we import, we need to spend in US dollars. If we export, we can earn in US dollars. And I have shown Sri Lanka with the exclusive economic zone for a reason. our country is not small. So we have immense potential to increase exports. If you look at the annual income, export income, goods exports, 2020, 2022, we have done quite well. Look at the effect of the recession and the COVID period. Overseas workers have contributed 7.2 billion US dollars in 2020, but it has gone down to 3.8 in 2022. Tourism has earned 4.4 in 2019, although with the bomb blast, it has gone down to 1.1. That means they are very volatile, those two. But goods exports are very resilient. It's very resilient. So we need to focus on that. IT and BPM is also a good sector which has potential. With Industry 4.0 technologies being introduced, IT and BPM sector will also do well. I'll get to that later. If you look at the monthly export earnings in billion US dollars, Sri Lanka earns just about 1 billion US dollars through exports. If we compare that with our regional countries, China obviously has huge potential and huge earnings. India, 38 just per month, half of our GDP in just 1 month. So we have countries producing in the region, countries producing and focusing on exports. So why not us? If we compare ourselves with countries in the region, this is how we are. The yellow line shows our contribution, our share of exports. If you compare with some good countries like Vietnam, Thailand, who are focusing on exports, they are having a 90% share of the GDP for exports. So, and if you look at the curve for Taiwan, in 1988, they have taken a decision to have a lead in terms of GDP contribution in exports. So we also can do the same. If you look at the SME sector in Sri Lanka, it has over 1 million enterprises. That's over 80% of the total enterprises in Sri Lanka, SMEs. It has 45% of the total employment, and it contributes 52% to the GDP when we compare all SMEs. And it contributes 80% of the export earnings. Now, if you look at the performance in regional countries, only South Korea is doing better than us with the SME sector. Others are not doing like what we are doing. So we have potential with the SME sector. We can move forward with the SME sector since it has a good proportion of industries. If you look at the industries, manufacturing industries account for 84% of the industries in Sri Lanka. It has, in the design and manufacturing area, it has about 1.4 million people employed, and that's 95% of the workforce in industries. And it contributes 18% of the GDP from the design and manufacturing sector. So we have this potential within us. If you look at the industrial exports, it accounts for 13% of the GDP, and the key exports are apparel and textile, rubber products, close to 901 billion US dollars, fabricated metal products, 1.7 billion US dollars. I had the other tables to compare these figures with the other sectors. If you take the tea, rubber, coconut, and spices, we are doing well. But if you take the tea industry, we have 200,000 hectares of tea. Employment is about 1 million people, but we earn 1.2 billion rupees per year. So we can improve productivity in this area and to have a better income. Rubber sector, we sell raw rubber, 41 million US dollars, and we have rubber products also. We do rubber products also. Sometimes we import rubber as raw material for our industries. So that's the situation. So we can upgrade the tea, rubber, coconut, and spices industries, and maybe we can do value addition. But we need to be competitive in the global market. And minerals, again, 50. I'll come to that later in my lecture. Now, if you are to upgrade the SME sector, what are the challenges that we have? We lament about cost of production. We always, there's a complaint about the lack of working capital in the industry sector. The availability of physical infrastructure for the industry sector. Technology use, very minimal use of technology. Even if we are using technology, they are very primitive, outdated, obsolete technology. And the demand is declining, probably because we are not so competitive in the global arena. And we don't have access to markets. There's no help from different bodies to access markets. And we don't have much technical and managerial skills required to make the SME manufacturing sector competitive in the global arena. And then access to information and advice is very minimal. Business development services are there, but not accessible at certain times. And then intellectual property rights, because of the property rights litigation, all that, people are afraid to move ahead as the SME manufacturing sector. Industrial relations and labor legislation is one barrier for the growth of the SME manufacturing sector. Then linkage formation and environmental issues. That's also identified as a challenge to upgrade the SME manufacturing sector. One of the key issues that we have in the manufacturing sector is the availability of raw material. And due to these challenges, many businesses fail. Among the SME sector, the rate of business failure is 45%. It's very alarming. Every 100 SMEs that the country sees today, 45% go bankrupt. They fail due to the challenges that they encounter. And at least 30% new establishment fail within the first 2 years. And 49% fail within the first 5 years. So this is the situation in the SME sector. So we need to give a helping hand to the industry. All this while, I've been doing research. My work has been in production and operations management and industrial engineering. My focus has been to improve efficiency and add value to the transformation process. This diagram was first showed to me by Dr. Julian Nanaka when he did industrial engineering in my final year. He said, inputs are there. We subject these inputs to a process of transformation, and we convert the inputs into goods and services. And we need to make this process efficient as much as possible. How can we do this? We have started with Industry 1.0, where mechanization was there, steam power was used, weaving loom was mechanized. That's Industry 1.0. Industry 2.0, we moved from there to mass production. The production lines came into being, and electrical energy was used. From there, the industry developed to Industry 3.0, and automation, computers and electronics came into being, and industries were transformed as automated systems. Now we have moved, the world has moved from there to Industry 4.0. We talk about cyber physical systems, we talk about Internet of Things, we talk about cloud-based networking systems. That's where the world is heading towards. But as the SME sector, we don't have these technologies for the SME sector. So we need to introduce these technologies as quickly as possible so that we can push our SME sector to be competitive, globally competitive as an industry. So what is this Industry 4.0? One tool in Industry 4.0 is the digital twin concept. In the ideation process, we can use the digital twin concept to develop products. Concept generation phase, design analysis phase, we can use the digital twin without having a physical system. Then we can go to the production digital twin, where we can use different technologies like plant simulation to see how the production works while just on a desktop. And we can do simulations and see how the production run works and what are the bottlenecks that are there. All that can be looked at during virtual production, in the realization process. And during real production, we can monitor how the product works, how the product is being assembled, and so on. And we can make adjustments in the virtual environment so that product failures are minimal when it goes to the market. Then when it comes to real production, in the utilization phase, we can look at the product, how it performs until its end of life. If we manage this process in the virtual environment, we can save a lot of money and we can be competitive in the global arena. With that, we can make our products the order qualifiers, we can transform order qualifiers to order winners. So we can make our products order winners. If you look at the Industry 4.0 technology, it transcends beyond the design and analysis phase. It takes into account marketing, pre-sales, engineering, purchasing, manufacturing, until service and repair and end-of-life management. And it builds upon a common platform where people from different parts or physically different locations can collaborate through the cloud. And there's an ISO standard for this collaboration platform, collaboration format called JT. And as Sri Lanka, we can be our industry can be in Sri Lanka and collaborate with different continents in the world. And in this, we can collaborate in terms of design, simulation, production scheduling. When it comes to production management, we can play our part while being in Sri Lanka through the cloud. So the BPM sector can flourish with these interventions. So how can we incorporate this Industry 4.0 technologies into our industry sector? I've come up with a strategy. Although R&D support, marketing support, I've not done much research on, My main research areas have been in design and prototyping support and training support. But for the sake of completeness, I'll go through all 5 facets of the strategy that I propose. If we look at the R&D sector, we need to do R&D for commercialization. At the moment, we do a lot of R&D as a country, but we don't put much emphasis on commercialization. We need to do R&D for commercialization. But in order to do that, we need to have support for this process. Bank loans on concessionary terms that can be arranged, an exemption of duty for production machinery. One example I'll quote, if you look at this sewing machine, traditional sewing machine, unless we do sewing at home, we don't buy a sewing machine. It's just a piece of an ornament if we don't use it for sewing. Similarly, we don't purchase a production machine if we are not manufacturing anything. If you don't produce, nobody will purchase a production machine. So why not give duty exemptions for production machinery? And tax exemptions. Some time back, we had a policy like that in Sri Lanka, 300% tax exemption for R&D. That's a very good initiative. And my proposal is to make compulsory keeping 10 to 20% of the profits for R&D. And they can do R&D in-house or in design and prototyping support centers, which I will discuss next. So design and prototyping support, how can we do that? My main research area has been in this. Design and analysis can be done on computer now. Industry 4.0 technologies give us an ample opportunity for us to use the cloud-based technologies for design analysis. We can do designs for corporates in the world. We can design products in a very cost-effective manner. We can do simulations for the global players. We can do simulations in-house. In order to do all these things, I can remember Professor Gopura and myself supervised a project, master's project, developing a layout for the food processing industry. And that process was used at GlaxoSmithKline, and they used it successfully. Why not? We published that. Why not use that technology? Why not use that finding through the Industry 4.0 technologies? Why not sell that to the industry outside Sri Lanka? So things like that can be done. If we take design analysis, Anushika, my PhD student, one of my PhD students, she is developing a head helmet for increased safety and fit. She is doing this project entirely using Industry 4.0 technologies, the new design software. And the design analysis is being done here. Now, when it comes to prototyping, we are looking at ways how to prototype, do the prototyping and testing in the virtual environment itself, which will reduce the cost of production at the end. So like that, we can provide centers for the SME sector to do the design and simulations in these centers. One good example is the design and manufacturing die and mold center that we have at the University of Moratuwa. We are trying to expand this to have all this entire capability. And in time to come, with people being trained in the relevant areas, we can expand this. I propose this to be expanded to the entire country, to all the zones in Sri Lanka, provinces in Sri Lanka. So we can have 9 different centers. If we need more, we can go for more. By the time we expand the centers, the SME sector will get automatically transformed into entities that use Industry 4.0. In terms of training, we need to infuse this knowledge to the primary, secondary, and tertiary education sectors and for continuous development of the graduates. One research that we did some time back, Dr. Kokila Abeko, she was the student. She did her PhD under my supervision, mine and Dr. Julian Nanaka's supervision. What she developed was a tool that can be used by the industry to recruit people with disabilities to industry. So if we can, there are 15% people who have some form of disability in the world. If we can harness half of that, train half of that to work in this sector, train them to do simulations, to train them to do design, they can be part of this industry. As my contribution to the nation, I have been involved with the technology sector, engineering technology sector. So training for school children is a must. So we can introduce these technologies to the school children to make them tech savvy so that they can contribute to the industry. In terms of material support, just like the blood bank, sorry, there's a typo. Just like the blood bank, if we want blood, we say O positive blood is needed, and the blood bank provides it. If as individuals we look for blood, it's very difficult to find. Similarly, for materials, we need to do the same thing. We need to get the requirements from different SMEs, processed through a centralized system, and ordered through a centralized system so that we can cater for the local raw material need and the imported raw material need of the SME sector. I propose this since our friend Dr. Jayatu Samaravikrama is the head of, is the Director General of the Nerd Center. I discussed this with him, and he did this. He tried this with construction material, and he was successful. He was able to give construction steels at an affordable cost to the industry. We can do the same thing for manufacturing steels, for electronic components, for plastics, for tool steels. For all that, we can do the same thing so that we can purchase material at a competitive rate. Going further, as I showed earlier, we have 517 square kilometers of ocean as the exclusive economic zone. We have proposed to acquire 750,000 square kilometers of ocean area to Sri Lanka. What does this mean? This means we get a resource of material. A bucket of water from the ocean is money. A bucket of sand dredged from the ocean, the bottom of the ocean, is money. If we can harness this, we can get the material required for our industries. We need to develop this, and we need to develop Industry 4.0 technologies to minimize the cost in harnessing this material. In terms of marketing support, although this is not my forte, we can connect with the global supply chains. We can do branding. Marketeers can do the branding for our products so that we can sell the products in the global context. at an affordable, competitive price. And as engineers, we can contribute by using modern technology to reduce the cost of production and doing BPM for global businesses using cloud platforms, using Industry 4.0 technologies. This way, we can move forward as a country. In summary, I would say design and manufacturing SME sector has a potential, very good potential. And it has numerous challenges. We all know that. Industry 4.0 provides us an opportunity to collaborate with the rest of the world in a very competitive manner. Because of that, we need to strategically move towards global competitiveness. Unless we do that, we'll not be able to have an income, we'll be in debt forever. And Sri Lanka has more than enough resources to do so, both physical and human. With that, I conclude my lecture. Yes, we can. Thank you.
Thank you, Professor, for your expertise sharing with us. Now I would like to invite the Dean of Faculty of Engineering, Professor Himan, to hand over the token of appreciation of the event of the event to our speaker. And once again, I would like to invite Professor Himan Punchihewa to explain. Thank you, sir. Now I would like to extend our thanks to our sponsors. The event sponsor, Carpet Private Limited, the print media sponsor, Daily FT, and our social media sponsor, Sri Lankan Scientist. Finally, thank you all for joining us. Have a good day.